This video is brought to you by ArchiTech Network and our online platform of courses where you can learn from world-class architects working in some of the practices that you can see in these videos. You can learn Grasshopper, Revit, Rhino Inside, Twinmotion, and some of our new courses on AI, and lots more courses that we're delivering over the next year. So please, if you like this video, check out our courses in the link below so we can keep bringing you more content like this.
What's up, guys, and welcome back to the ArchiTech Network. We're here with another one of our ArchiTech tours at the one and only Zaha Hadid Architects. This should be a super interesting one. We're going to be talking with Shaajay and his code team at Zaha about the technology they use and how they work behind the scenes of these projects. This should be a really interesting one, so without any further ado, let's go check it out. All right, guys, we are here with the one and only Shajay from the code team, and he's going to show us a little bit around the space and some of the work. Luckily, we've arrived when you have a little exhibition of your own stuff, so that was unplanned, but perfect. And then we'll talk to Shajay a bit later about some deeper questions. So thanks for having us.
Yeah, thanks Ollie, thanks for coming, and thanks for the opportunity to show you around, but also talk about, topics that are close to our heart, I guess, so the gallery here is to try and showcase all, it's a public facing front of ZHA, and so we want to showcase through the gallery not only our work, but the fact that our work is always collaborative with artists or with suppliers or with engineers or all kinds of creative professions and who are interested and share the ethos of combining technology with design, right? And so this particular exhibition is it's exhibits that are hosted here, which usually travels as part of our 4 to 5 exhibitions that we do every year, and so they're just interim here.
So this is where you keep them.
Yeah, and we kind of mock up the display, let's say, before it goes to the exhibition. And
so this timed it well to come here.
Yeah.
This is a very famous piece by you guys.
Exactly. Right? Yeah. So this was a collaboration with AI Build, it's actually co-founded by 2 people who were here and were employees of ZHA for a long time, and then they spun out a startup called AI Build, which is now very successful, growing. And so at the time, we also were working with hot wire cutting and another startup, a robotic fabrication startup called Odico, which does hot wire cutting. So this particular installation or sculpture combines 2 things, 2 fabrication technologies. One is to make a mold, which is wire cut, that you can see there. The blue, the foam was cut using a bigger version of a wire cutter like this. You take a big block and you cut it out. And then it was one of the very first times that AI Build or anybody in the world was printing, 3D printing on top of a curved formwork. And some of these prints were almost vertical, 90 degrees, hanging, right, cantilevering. And so that was interesting, the attempt to combine these 2 fabrication technologies. But with each fabrication technology, we also pair it with a kind of custom developed design technology, right, that a way to create these shapes that take full advantage of the opportunity offered by the fabrication technology. So here, because the plastic extruder doesn't like to start and stop that much, so we had to so we designed this thing as one continuous curve, 7 kilometers of curve that is wrapped around a ruled surface. Ruled, why? Because it can be then cut using a wire cutter, and the mold can be made and then you can print. So you can also see that we created this kind of digital generative algorithm that creates these curvy paths and also densifies them at the edges so that like there's more stiffness and removes material in the interior. So we developed that kind of custom workflow between digital process that is bespoke, developed for the printing process to take advantage of the printing process. And so there's also a physical analog to that, right? Like, you know, how did we create these curves? You know, if you take a full box and you just keep inserting these cable from one end, it naturally produces that kind of you know, yeah. And so we just use the same principle and created a digital algorithm that does exactly that.
Mold, and then it just prints on top of it.
Yes, actually it was it was one giant mold digitally, but in physical reality we had to cut that into so that it fits the size of what the robot can do. And so there was about 8 or 9 foam blocks that were, and it was 6 or 7 pieces of 3D printed, which, like, you know, here we're kind of connecting them together using these connectors. You know, it was never meant to be. It was meant to be like a 3-week thing in Milan, but it turned out to be here even 7 years later. It's been in China and like in the Maxi in Rome. Yeah, it's taken quite some beating, and so we're now planning to retire it, or at least hopefully AI Build can build us a new one.
Still looks good.
Yeah. This exhibit tries to demonstrate a few of our technological investments into so-called participatory design, or online communities and how they can be translated into on-land residential units. So this is a project, like an experimental project in Roatán in Honduras. So we created this video game, which is based in Unreal, and people can log into this video game and customize their house. But what's also more interesting is that you can choose your site in 3D and choose your neighbors, or invite your neighbors to come be next to you. And so we are leveraging real-time gaming technologies to allow people, non-experts, to create their 3D cluster of houses. And paired with that game is the idea of, you know, every time you make a change, like, it updates the cost. So it's trying to gamify one of the most expensive decisions you make in a life, which is to purchase a house. So it's trying, and so it obviously has to incorporate some of the manufacturing time and cost criteria. And so in Roatán, like, there's a lot of tropical pine, like, it's not like Swedish pine, like it's like tropical pine. So we collaborating with a another startup called Circular Factory, and Circular Factory basically brings robots rather than bring the entire pre-made house. So it brings robots and software onto the island and uses local material, but also upskills local labor to participate in the digital economy. And so these two pieces of innovation, on the front end, there is like a pre-sales configurator, online configurator, where you configure the community and the corresponding houses. And then the back end is like, you know, physically realize it using so-called micro factories. Yeah. Which, you know, typically modular housing requires you to create like a factory which is like 150 million, and then you have to make hundreds of houses. So small number of houses in a remote island, like, which takes advantage of digital fabrication, is usually not feasible unless you try to innovate in this way with the technologies on the front end that does the pre-sales. And then the rear end, which also does the micro factory. Yeah,
the whole building a factory for 150 million hasn't worked out too well.
No. So far. Yeah, so this is a fraction of the cost. Circular Factory for 150 million, I think they can populate the entire world with factories. Like, so,
interesting. And this was, I've seen videos, this being CNC'd with robots and things like that.
Yeah, so this is, these are prototypes produced by Circular Factory. Pieces of the so-called bullnose, or the balcony of one of the houses. So this was in Roatán in the tropical heat and rain for, I don't know, 16 months. So it's taken quite some beating. And so in the meantime, they've upgraded the gluing process. So they've come up with their own custom ways to do glue lam on the island, which is very difficult already to do even in well-developed economies. And so now they're trying to get it certified and like also train the local people to produce these kind of things. So it is an experimental project, like which is also meant to eventually become a city. But right now it only exists virtually. It's perhaps one of the most famous unbuilt project of code. Yeah. So similar to Thallus, so this is Striatus, a collaboration with the Block Research Group in the ETH Zurich, and Incremental 3D, a startup that does 3D concrete printing in Innsbruck in Austria, and Holcim, who engineered the material for the concrete ink, and also made the logistics possible and paid for sponsored the prototype. So what it tries to demonstrate is a kind of a new way to use concrete, or a new language for concrete, also that unreinforced masonry. If you think of concrete as a synthetic or artificial stone, you can design structures that take advantage of unreinforced capacities, compressive capacities of concrete, right? So stone is similar in that sense. It's very good in compression, not very good in tension. So that's why, the Roman art, footbridges or aqueducts always have these arches. So that's what we're trying to showcase here, that if you think of concrete as a synthetic stone, you can leverage all the masonry design techniques and also the shape possibilities from more historic times. You can start doing Gaudi-like things, which is a kind of lost art already, because it takes a long time to chisel away stone. And so the concrete printing offers you all the benefits of masonry construction, which, the famous saying is that if a masonry structure stays up for 5 minutes, it's going to stay up for 1,000 years, right? So it's a similar idea that that's a benefit of unreinforced masonry.
Yeah. And this is the one-to-one?
Yeah, and this is one of the blocks. So we 3D printed 53 blocks to create this particular bridge, which was assembled. It's completely dry assembled, right? There is no glue in between. So, which means it can also be disassembled and it can be crushed. Because there is no fiber in this one, there's no steel in this one. And so it can be completely crushed and made into new ink up. You don't have to downcycle it. You can actually make new ink out of the same concrete. Because concrete, usually when you recycle it, you downcycle it, right? It ends up in road ballast or things like that. And so by here, Holcim crushed this bridge, and we made another one called Phoenix with new ink, which is even more carbon neutral, 30% less carbon in the new ink. And you can also see that unlike natural stone, you can make hollow stone. Yeah. So the bridge is significantly lighter as a consequence. And similar to Thallus, this also showcases integration of digital design processes that take advantage or are fully aligned with the way things are physically made. Because the robot only needs to figure out how to these paths, so where it deposits these concrete as it goes along. So that's what we designed in the digital process with Block Research Group. Also part of my PhD was how do you create a workflow and a new geometry creation technology that is both unreinforced but also can generate these print paths as the output. So we are bypassing, requirement for plan sections and these kind of things. Talk directly to the machine. Yeah. And what's incidentally, the entire file that has all the geometry details, all the structural details, and all the fabrication details is just a few megabytes. And so, and we were able to pass it around during COVID, like none of the three teams met each other. One was here in London, another in Austria, and the third in Zurich, and the construction was happening in Venice. Like so.
Yeah, very beautiful projects.
Yeah, thank
really
you.
cool story behind it.
That's Adam, our digital prototyping lab lead. He makes all the cool models. He operates all the printing machines and outsources.
So this is model making, robotics, R&D, all of that.
Yeah. And I was also wanting to showcase like our expertise and interests and investments into robotic making, and also to illustrate to clients that there is an entire ecosystem emerging, that can make things cheaper, more circular, safer for construction and so on. If only we can reimagine like how things can be constructed. So yeah, it's a more like a show lab, like it's not fully production oriented, but right now we are doing wire cutting, but we can also the lab is configured or designed to be able to have extraction for lightweight milling of timber. We can do 3D printing, and we have some circular saw and things like that. So these stairs have been here for about 12 years. Like the first. They were each of the stair tread was meant to be slightly different, but in the end, there were only two types of treads.
Wow.
It's basically a hanging stair, so all the treads are hanging off of these steel rods. Wow. So this, we had the office was split into two buildings, and there was always a gallery here, and like most of the office was upstairs or in the boys' hostel, which was famously where Zaha started in one little room, and then she bought that little building, and then the next one and so on. We had the entire, but then when she passed away, it went to the foundation. We moved the entire office here, and then COVID happened, so we got the opportunity to refurbish and rearrange the office. So now this is a much bigger gallery, and then there's a tech lab downstairs where, and so we host in the gallery like all our public-facing activities. Like we try to have tech events, architectural, cultural design events, or diversity and inclusion or community engagement, outreach events. So it's a kind of active public-facing part of it, and that's also been very useful for people always peering through and looking
at the models. Obviously, we got to talk about this guy. I'm somewhat familiar with this project, Morpheus Hotel.
You probably know more about this than I do.
I guess for the audience listening, I spent about a year and a half of my life trying to solve this part of the building. I was with France, we were working on the panels, how to fabricate the panels. I mean, it was a crazy project to solve, but pretty amazing. And I know the interior spaces of these are really incredible.
Yeah, I mean that's one of the things about almost all Zaha projects, because they take so long to be realized, when they're so innovative in all multiple dimensions, that they spur or kickstart many a career. Not only within the company, but also in the extended ecosystem.
Myself included. This is where I learned a lot of more advanced grasshopper stuff.
Exactly. So we always think of our projects as vehicles for pushing the boundary and figuring things out. So unless you have challenging architectural tasks, there is no real push for technological innovation. So a similar story for actually these Cork walls as well.
Talk to us about the wall. It's super cool.
So this is a Portuguese supplier. They make custom Cork wall panels, and But this is the first time because this repeats across the entire core and all the 4 floors. So this is like a Zaha painting that has been converted into this kind of relief.
Right.
And we had to compute all the tool paths because it's not like a regular XY tool pathing. Like so we computed that, and also the relief in itself, like converting an image into relief, which is a technique that Zaha herself was made famous. This 2.5D relief model. So this is about like the Hong Kong peak. So if you look from further away, you will probably recognize.
Yeah.
Every floor there is like so this is the earliest painting, and then like the top floor is more curvy, the latest projects, and so this Cork wall had to go through quite a lot of testing and iteration of the tool paths, and also fire testing and like mounting and so on. Yeah.
That's very cool.
So yeah, it's been a vehicle for innovation, even the small thing like a wall, and the tech lab itself also quite challenging with all the, AKT did quite some innovative engineering to not rest the robots.
It's not that easy to just plonk a robot on the floor, right? So.
Yeah. So it's been, so it's trying to showcase that technology is a silent partner. Like we try to not make it so visible, but obviously to achieve some of these things we have to have a mastery over the.
Yeah.
So this is a collaboration with Techno, the Italian modular furniture company, the furniture company, and this is their modular series. I forget what it was called, Cube or something. And so Zaha designed one module for them called Thallus. And
you can get the whole thing.
Yeah. Well, it took them. It was assembled here in pieces. But what's interesting also is that the floor is another startup called Actual, and they've made the floor for all of Schiphol Airport. And what's unique about this floor is that they 3D print a bioresin, like the pattern, and then they put terrazzo, hand terrazzo in. And so you get like a monolithic terrazzo with like digitally fabricated inlay.
Wow.
Yeah. So like this gallery is like a kind of also a subtle undercurrent of like all the collaborative startups that we're engaged in. That one was designed for the Science Museum in London. It was a collaboration with a startup called Odico in Denmark. So there were 16 benches. So this is like a prototype bench. Each one was unique, and that fits uniquely in the 25 stories about mathematics in the gallery for mathematics. Yeah. It's one of the earliest things Zaha herself designed, but now they've reupholstered it. So we used to have a store here, which now is moved online. Yeah. Hello, my name is Shaajay. I'm an associate director here at Zaha Hadid Architects. I also co-founded the Computation and Design team, which I now continue to head.
Shajay, thank you so much for having us. It's been amazing to see the space.
Sure.
It's a really cool space that you have here. Seems like a really nice place to work. It's quiet. You can do your own thing. Maybe to start things off, let's talk about an overview of the co-team at Zaha. What do you guys do? What disciplines of design technology do you cover? BIM, computation, immersive. Give us a bit of an overview of the co-team.
Okay. The Computation and Design team, short code, has been around, was founded with Patrick and Niels and myself about 17 years ago. And it's continued to evolve in its mandate and its methods as the firm has grown. When we first started, it was like the company was maybe about 120 people. Now we're up to 500 plus. And we also now increasingly do more physical build projects. So the first decade or so, we focused entirely on so-called architectural geometry and building up expertise in all the geometry processing methods, like in its relation to computer graphics. And since then, it's like just been applying those things and adding to that, like various domains of investigation and application, things like digital fabrication, or robotic fabrication or manufacturing, and also lately things like the Metaverse, and also things like modular design or prefabricated mass customized buildings. So we continue to evolve, but our core expertise is around geometry, architectural geometry, so to speak, and then geometry processing. Yeah.
And what other kind of DT teams are in Zaha? For example, do you have a BIM team or a visualization team as well? And do you guys work with them much?
Yeah, so the code team sits in the technology cluster headed by Niels Fischer. And code is the oldest team, but then there are other teams there, like there's the BIM team, there's the analytics and insight, which is office space planning and occupancy design and analysis and so on. We also have a environment and sustainability team, and we have another research team called AI ZHA Social, which investigates agent-based simulations of human populations within buildings, but not evacuation, but actually functional crowds that going about their daily life within a building. Yeah, so and we do interface a lot with environment and sustainability and the building occupancy, and increasingly we want to also unify our methods so that we can collectively offer services to the rest of the cluster, so to speak. So the technology cluster is internal facing, all our clients are projects of the office. We don't have clients outside. Yeah.
Give us a broad overview of the tools and technology you use, and we really mean what on a day-to-day basis are Zaha designers using, designing in Rhino and Maya, Grasshopper, Twinmotion. What are the tools you guys are using?
I think our predominant workhorses are Maya and Rhino. And for our architecture firm, we are in that sense maybe peculiar that we have a workflow or a production workflow similar to movie industry or animation industry. So we start, I would say most of our projects start their life in Maya, and then it's simultaneously back and forth between Rhino and Maya, for the most part. Yeah. And so we have and typically we win most of our work through competitions. So buildings have to be delivered twice at least, once at the early competition stage, we have to render it, so we have a lot of tools towards preparing assets for rendering. Even though we don't do in-house rendering, we have to prepare the file so that we can send it as instructions. And we also do a lot of test renders, in Unreal, real-time renders in Unreal, and increasingly also using some amount of stable diffusion to quick AI generated or AI touch-up. So on the first front end, let's say for the competition phase, and then subsequently, if we do win it and the project has to go into the next phases of construction, then we start documenting the building in Rhino and also interfacing with the BIM side, with Revit, but increasingly also, depending on the complexity of the building, we might have to interface with the facade consultants in a CATIA format or whatever format they're using. And so in all of this, I think we remain somewhat agnostic to software because we never know when some of these things get updated or so we do maintain a core code base which we have developed over the years, and that code base exists in C++ and also in C#. And so that allows us to interface with some of the machine learning toolkits like PyTorch or TensorFlow. for the more advanced analytics. Yeah.
Have you seen any particular rise of one? Like you mentioned Unreal, for example. We've also heard other firms getting quite excited about Unreal, and I know you guys have done a lot in the Metaverse. Are you seeing more of that kind of thing, or is there particular software on the rise, so to speak?
Yeah, of late, like we've been very interested in like Omniverse, for example, like because we always borrowed from the animation industry, and like so file exchange and not real-time file exchange between departments, so to speak, is been important for us, and we've always had like ad hoc solutions or like kind of homebrew solutions, and Omniverse is beginning to offer some of that professional tooling for version control, for real-time transfer of files, streaming of files like to iPads and whatnot. So that's very exciting, and which also helps us process files for both rendering, but it's the same for the metaverse in a way, right? Because like the metaverse is mostly powered by gaming technologies on the content generation side, and so like we use Maya, we use Unreal, like, and we also use increasingly Omniverse to maintain our repositories. So yeah, like I think those two aspects are beginning to be very exciting for us because all our prior investments are kind of beginning to be self-justified.
Yeah. Interesting. That's perfect. So obviously you guys are the computational design crew, so to speak, inside Zaha, but I get the sense that the designers themselves are usually fairly well versed, would you say, in computational design. How do you guys work with the project teams and also the designers? Is it as simple as like someone's tapping you on the shoulder because they have like a script that doesn't work, versus you guys creating big workflows to kind of streamline the design process?
Yeah, I think like we have had a unique trajectory, I would say. Like we originally started with the idea of having a kind of computational design team that makes tools and like deploy tools like firm-wide, and like that quickly didn't work out because like we don't have like repeat projects of like the same kind, and we're not even operating in the same market. Like so every project is like takes 5-6 years. I mean, originally it used to take 10 years, like, and since we're operating in China, it's now kind of maybe shortened to like 4 or 5 years. Yeah. And so like what we have aligned all our tooling and the way we interface with design teams to produce high performance buildings, like less about automation, more about ensuring that the design is of the highest quality and the highest value for the client. So what that translates to is that like our tooling has to be iteration friendly. So it has to be very quick. Like we want the 80% solution, not the 100% accurate engineering kind of solution, because we anyway have to have engineering consultants for that. So the way we interface with teams stems from that. Like we are deeply embedded in the project team. So we are only part of like maybe 3 to 5% of like all the projects in the company. Like so, we tend to be either part of very interesting novel projects or important big scale projects that has complexity of data or complexity of geometry. Because as you said, like the company is extremely self-proficient with like all the things it needs to deliver the business. Like, but so we're more seeking a kind of where things will be 4 years, 5 years, 10 years from now.
Yeah, you're like looking ahead. Yeah. I think that's an interesting point about. I had the same kind of struggle in creating toolkits, or as simple as like a Grasshopper library or something like that is really difficult in design firms sometimes, because designers bloody change things all the time and they never want to do the same thing. So the tool either has to be super broad, yeah, and then maybe not as effective, or effective but it's particular for certain things. That's always a bit of a challenge, right?
Yeah, no, absolutely. And this is also a kind of common problem in in code development, right? Like software development, like you can optimize your tools like and code so much, then it's very difficult to refactor it like for something else. Like whereas you need to remain agile, like to absorb like new research when you collaborate with every team. So it is very much. So in fact, like the other benefit we have is like everybody is trained as an architect, like, and we have core architectural degrees, and so we also trained ourselves to do more design with teams. Like over time, we now participate with design teams, like contributing on the design iterations. We just happen to use coding or like use some kind of procedural method to create the designs. And only in the later stages we are like looking at like kind of performance enhancement and like so there we beginning to have standardization and best practice, like things like geometry method statements, which help describe the building succinctly and also free of errors, so it can be things are not lost in translation from one practice to the engineering practice and stuff like that.
What about, are you guys involved in like training, for example? Like how do you maintain the average Zaha designer has that good level of Grasshopper or whatever they use?
We are actually not involved in any training of the staff. Like we are a kind of research group in that sense. Like so we participate in these teams directly. Whatever training happens is bi-directional osmosis, right? That like we participate in a project, we learn like the tips and tricks of like how designers are like quickly translating briefs into massing into shapes, and like then we begin to see, okay, there's an opportunity for computational enhancement of that process, and likewise, like we discover certain kinds of shapes, like things like topology optimization or AI technologies. And then the design teams get excited by that novel output, like, and so that's how over many projects we definitely are able to refine technologies in a way that we can problem solve for every client in a unique way. So we are kind of like we put together a custom stack for every project, like so.
So they pick it up from working with you guys and absorbing it.
Yeah.
Cool. I think that's great. So I know you guys are very on the kind of metaverse forefront of things and game engines. You create a level in PUBG. You've also got developed your own metaverse called Metropia.
Metropia, yeah.
Metropia. Talk to us about what you see the metaverse becoming for architects, and also how is code also involved in that side of it?
Yeah, I think our interest in metaverses, like or virtual spaces, stem from long history of interest or our ethos that like architecture is in the service of the user experience, and more specifically that architecture is hosting productive human activities. So whether it's it's in a stadium or in a city or in a physical world or virtual, like for us it's the same. Like the task is the same as architects. The profession is one of the few that is, or maybe the only one that is fully capable of designing for hosting these activities, right? And so of course, like in the physical world, like there's the additional constraints of physical realization and so on. But that's the same also in a way with the virtual world, that you have to, adapt to production constraints of other kinds, like polygon counts or texturing and so on. So yeah, whether it's online or on land, like we have the same, kind of ethos of total design for the benefit of the user experience, and it also needs to be co-located and synchronous human experience, right? Otherwise, if it's individuated, like and you put on these headsets and you don't see anybody else, you don't have a conversation, there's not much need for architecture. Right. So that's the founding motivation or basis of our interest in the metaverse, which is kind of translates also in some of the economics to of open world building in the virtual, like games and stuff, like translates to city building in the physical world, because like ultimately cities are also reliant on having citizens and metaverses are reliant on having a community and users, like because they drive the economy. And the other parallel is that like the virtual world, also people are attracted to a particular website based on who's already there and what interesting things those residents offer to the new migrant residents, right? And so it's the same in new cities. Why do people come to London is because the existing population offers them interesting things, and including labor and employment and so on. And so that's how we've been thinking about the parallels between online and on land. And so we do think of the metaverse as a very fast-paced sandbox to prototype things, like which are pure in the sense that it allows you to focus on the user experience and like the core competence and the core task of architecture, which is to host these human activities. And so once we prototype that, like then it's somewhat easier for us to then deploy it onto stadiums or other things like in the physical world. And so that's the parallel we see, and that's how we've been working on the topic of the metaverse. And Patrick's kind of laid out all the intellectual framework for that, and which we try to then supplement with like a technical, which again, like our prior history in using Maya and computer graphics and computer geometry for physical world architecture, like it just was a very like fish to water in a way, right? Because we were anyway using the production workflows.
You've also been like one of the first architects I've seen that's like built something in a very popular video game.
Mm-hmm.
I see a lot of people playing with Fortnite right now as well. Do you feel like video games is like this new place for architects to build work?
Yes, I do think there's like a lot of synergy with video games. Like one of the key things is that attracted me personally to video games is the compatibility of the technologies we were using anyway, but also that video games relies on user choice and user experience. Like, and strangely, none of the architecture software has any of that. Like, you cannot make a video game unless you encode like these two things, like user choice, user experience in its guts. And so that's what's somewhat interesting, like about video games. And so that could be a means to re-engage with civic participation in the built environment, which has throughout the 20th century taken a nosedive, which was not the case. Like people were pretty educated and had pretty vocal about architecture and its like their built environment and their habitation and so on. And that then leads to lack of pride in like their built environment, and like so we think that video games offer that like return to a potential re-engagement with the users of architecture, which like typically you're not actually designing for the end user because you're designing for the client, right? And so architecture typically has that principal agent problem, meaning like you're designing for somebody intermediate, representative of the end user. So, and video games try to go straight to the consumer, and that's quite a beneficial. So we did these projects where people can customize their house or like invite their neighbors to live with them, and so we're using these kind of configurator technologies to build communities. And interestingly, Patrick wrote a paper like 20 years ago called the auto generation or autopoiesis of residential communities, which kind of talked about some of these technologies. It's just now happening through video games. So.
That's very cool. So almost like for Sims for real life housing. You can build your own,
yes,
configure your own housing.
yes, exactly, and
but live in it in real life.
yeah, and actually Sims is a great example of like city building games, right? Like, so now we've gone from residential neighborhoods to, we increased that to look at city building games. We're now working with Epic on creating a demo experience in a similar way, to enhance, young people to participate in, understand the trade-offs in creating cities, creating architecture, like how you can be sustainable, but also like be engaging and so on. And so we took a lot of inspiration and from this game called City Skyline, which is the next version of Sims. Like, I mean, it's already 15 years old, but it's very interesting that like there's little Sims. Like if a city has 1 million population, there are actually 1 million Sims going about doing their life. Some of them are married, some of them are single, and so it simulates this idea that the city is a live ecosystem, and the size and shape of the city directly affects their lives, which no urban planning design tool offers you that feedback.
That's interesting, yeah.
And so you draw a road, and then like some citizens start going crazy, or you don't put a school, like they start complaining, and so it's like really fun way to understand urban design. Which is actually the fundamental basis of city design, right? That you want to keep your citizens happy, otherwise you don't get revenue and you don't get tax and so on. Like, so yeah, it's a fascinating way to formulate the problem of city design. That's another way games, like to me, are very interesting.
Yeah. So young architects listening, play some video games.
Absolutely.
It will help you in your design skills.
Yeah. I mean, also it helps you understand, like broaden your, geometric or formal repertoire too, like because you're not constrained by like what you think needs to be physically realized, and which is kind of interesting when you see all the AI tools. Like most of anybody using AI tools, like they're not making boxes, right? Like. And whereas like if you're using architectural tools, like most of people are making boxes, and so it's kind of liberating in that sense. Like video games could be liberating into the true essence of a problem. So
yeah, you showed us the exhibition downstairs where it seems like you've got a few 3D printing things. We were at AI Build filming yesterday.
Right.
Digital fabrication also seems to be a big thing that you're working with here at Zaha, but also with Code. And in a couple of different ways. You've got 3D printing, you've also got like the kind of customized modular timber elements. How do you feel digital fabrication could play a role in our construction industry? Maybe particularly 3D printing. Do you feel like we're getting to a point we could print buildings?
Digital fabrication, like for us again, it like ties back to our interest in so-called architectural geometry, right? Like, and so what is architectural geometry? Like if you think of a spline, like it's something that you can draw in Rhino easily, but it's also has a physical equivalent. So you can recreate that spline physically by drawing the same weights. Similarly, you can have stretch fabric, you can have like certain kinds of shapes that are geometrically abstracted on the computer, which when you have to physically realize them, you just recreate the physics. You don't have to draw a plan and section, like, so that's how we became interested in like digital fabrication. Like, so for example, like the Science Museum Gallery for Mathematics, like it has these complex curved surfaces, like so-called minimal surfaces. And like the way we could have tried to realize that by 3D printing it or like some other clunky way, but because there's a natural fit with like fabric structures and minimal surfaces, we got to interact with like tent makers and like digital fabrication of fabric, which UK has quite some history to and latent skill. So that's our interest in digital fabrication because it's digital in the first place. So it like directly connects to our digitally native design procedures. So it allows us to physically realize complex shapes which are high performance structurally or they're lightweight, but typically have been difficult to physically make because the production system for over 100 years has been optimized to make I-beams and like standardized boxes. And so it offers us a unique way, a way to realize these high performance geometries, which otherwise wouldn't have been possible. And increasingly, they're very, very economical because there is a lot of development in like all the universities of the world, like in ICD, in Stuttgart, or ETH in Zurich, and MIT, and so on. So there's a lot of rapid progress that we want to participate in. At the same time, we also want to inherit all the ancient or wisdoms of people like Gaudí, pre-computer versions of digital fabrication, because like all those complex churches and buildings that he made were incorporated in geometry, a method of describing it on site and a method of realizing it with material and so on. So yeah, that connection with geometry as a way to describe physical making and its structural performance is for us one of the key reasons we're interested in digital fabrication. And hopefully we increasingly see benefits of like printing in concrete or like wire cutting to make formwork, small scale digital timber, modular houses and things like that, not only at ZHA but also all our colleagues and peers elsewhere interested in these things. And so we hope like the industry can definitely upgrade itself because it also overcomes some of the sustainability burdens of like the current industry, like worker safety, material waste, and all of these things, or recyclability and so on.
So quality as well.
And and also like labor minimizing, like everywhere, like not only worker safety, but like young people are not coming into the construction industry because it has this sense that it is like a kind of gruesome or grueling industry, but actually like the injection of intelligence and like robotics like could be a way to also attract more younger people who can be entrepreneurial with these digital means of production, like AI built, like
exactly.
Yeah.
Obviously, we can't come around here without talking about the elephant in the room right now, which is, of course, AI. We've been asking everyone that we come with, like, how are you guys using AI? Are you using AI, and what excites you the most about, this crazy world of AI that we're seeing in the AEC space?
Actually, yesterday there was an interesting presentation by Mark Berry about the Sagrada Familia and the genius of Gaudí, and one of the things he mentioned like kind of struck to me that that AI is a kind of franchises the amateur, and that is actually very good for the profession because it brings everybody up. Like you have to innovate, like to stay ahead, and so and something like that actually happened with like web design. Like when the internet came along, like graphic designers everywhere had to up their game because there were so many websites to be made and so on. That's where we think that currently the AI explorations are super exciting because it can up the level, and it can also provide maybe a way of kickstarting the creative process, like particularly these text-to-image AI. Of course, there are all other kinds of AI as well. And yeah, so it refocuses energies into the profession, which is always great. But also, we obviously need to redirect the AI to fundamentally useful tasks. Like otherwise, like quickly dies, right? Like if it's not directed at solving some like great problems, like AI is maybe like trying to use a giant machine to kill an ant kind of problem, right? Because most problems wouldn't need AI, like, so we have to find problems worthy enough for AI on the first principle on the first hand, and then second, also AI cannot naturally solve all kinds of problems, at least the current AI. Like so, in particular, we are trying to focus on the so-called sequence-to-sequence anatomy of the current AI, right? That so, what like ChatGPT, you put in some words and it gives you a longer list of words. So it's a sequence of words that gives you a sequence of words back as output, or sequence of words can give you a sequence of pixels. So text to image or text to 3D, like all of these are like sequence to sequence kind of tools, like or technologies. And so we are now trying to think like, what kind of architectural tasks there are that they're important to solve, and B, can be formulated as these kind of sequence to sequence problems. Like so the base level is obviously to just use Midjourney and Stable Diffusion and so on, just to kickstart the creative process and front load the creative process. Basically, you engage the client early on, which I think is quite remarkable, because like previously, client has a brief and then you have to spend a month making designs and then render it and then go to the client. They don't like it. And now you can get them in and make quick sketches with words. Yeah. And it gets the client in, and it also can bring in senior designers who might not be so well versed computationally and so on. So I think that part has been very great, that it front loads the design process quite well, and then quickly, client also realizes why they need architects, because they'll say, how long does it going to take to build, how much is going to cost, and then that's where our professional skills and training really comes into play, because we have to interpret these images as buildable, as engaging 3D spaces. Even if there's text to 3D, that's not going to come without professional training, right? That interpretive act will always be a human-led. So the other AI we are very much interested in is this idea of Copilot, because we are a very human resource-based business, right? Our predominant cost and our greatest assets is all our designers. And we are not a vertically integrated company, or even not a full service company. We're only architects. So we collaborate with everything else for everything else. So we have to be absolutely top notch in the design side. And so anything that we can help designers be augmented, we are very much interested in. So whether it's Copilot writing parts of your code, or Copilot beginning to aid you from day-to-day tasks, or even contractual agreements, ChatGPT is very good at figuring out certain clauses, and so so in all these applications we're very excited by AI, to be honest, but of course one of the big worries we have is that AI will find its way or will be directed towards problems that humanity needs solving, and because each training costs I don't know, 5 million or whatever, it costs OpenAI, and even if that training cost comes down, all of these GPUs have to be directed at something that humanity needs or society needs, and architecture is definitely one of those things. But it's up to architects to formulate the problems so that the people in the tech world can see it as a opportunity to advance AI and also monetize the technology, which is what we are trying to do, and I'm sure others are also figuring that out.
Yeah, super interesting. Do you feel like there's a concern at all for you guys specifically at Zaha, but also other architects, right? That anyone can now type in Zaha Hadid Architects, and I'm sure it's one of the most used architecture prompts, right? Do you feel that is a concern, or actually it makes you more valuable because more people maybe get to know your work, your style, or what is a Zaha building?
Yeah, I mean we've been fully embracing of the technology, and because our IP is in the design. It's the license that we give for the building to be realized virtually or physically, and so that's what we get paid for, and it also increases our brand recognition, and so all of that is great. Anyway, I think it's like a bidirectional thing. Like the AI trained itself on all these images, and as it happens, like in the last 10 years, maybe Zaha Hadid Architects have like quite a lot of built work and photographs and renders, and so it's natural that like there is a bias towards ZHA in the prompting, and so it also helps us in a kind of indirect way because one of the ways that firms are trying to engage with AI is so-called the refinement phase, right? Like no architecture firm has like the capacities to train the base model. Everybody's trying to do the fine-tuning model. Yeah. So because the base model contains so much of our work, like our fine-tuning phase happens to be quite much easier. We don't need so much more additional data to do the fine-tuning. Whereas if you're not heavily featured in the base model, like it will be much harder for you to tilt the model towards like what you want it to do. And so it's kind of interesting that in an indirect way that's actually helping us. And also, as I said, that yesterday was both Patrick and Mark Berry were saying that like it ups the game for everybody, and so it's great that like there is that competition, and so we're definitely not in any way worried about loss of IP or things like that. But the only real concern we have is that some of the things like technical and refinement, like that shouldn't get lost in that. Like we should always try to make architectural tasks to be foregrounded, important architectural tasks to be foregrounded for AI to solve. Otherwise, it might just be directed at trivial tasks and like Instagram fame, and then like after a year, like nobody figured out how to make money, and then it's gone.
Yeah. That's an interesting. We'll see how that pans out.
Yeah.
So another question we've asking a lot of people is, for young architects or a student out there that has aspirations to one day come and work at the code team here, what kind of things do you look for? What kind of things would you advise if they want to get into computation? What advice would you give for aspiring?
I think, like because we are an architecture firm, so design comes first, and technology is always in the service of making our designs better and our designers better. And so it's very less to do with automation and that kind of skill sets. So it's more broad, that there needs to be a cultural appreciation of like the role of architecture and the importance of architecture. Otherwise, clients don't pay us to make everyday buildings yet. And so we always we have to sustain the tradition of patron-led innovation in the built environment, right? Like, what does that mean? There's always architecture has progressed through investments by society or patrons, for building of churches or secular buildings, and there's not been any other way to innovate in the built environment. So a Zaha building, like any other big firm building, is a economy of itself, right? Because you build a stadium, right now it costs $1 billion, and so that money flows through hundreds of firms, and so an innovative project will fund many other things, and so that's a skill we need. We need to convince society and investors that innovation is important, and that's not a straightforward task. It's not A to B. It's an uncertain task. So the core skills we look for are geometry processing and shape design as a core competence, and then some cultural understanding of the role of architecture. And mostly it's a kind of entrepreneurial mindset to be able to. It's going to take a long time to see your first building built, and so generation after generation, they work for 10 years and then they finally realize one of these buildings, like the Azerbaijan building was one generation of architects, and then the Beijing airport was another generation of architects, and so it's generation after generation that creates all its network of collaborators and techniques of designing. And so that's why there is no Zaha style, per se. Like if you look at early, very angular, faceted to like the Beijing airport, like there's a vast actual range. So I think, yeah, it's, being core expertise is geometry and shape design and entrepreneurship, and willing to stick it out for 10 years.
What about if someone wants to start getting into computation? Where would you just advise them to throw themselves into Grasshopper, for example, or get into full coding?
Yes, I think video games.
Video games.
Video games, yeah. It's like the funnest way to learn about math. It's the funnest way to learn coding. It's the funnest way to learn about design too, because nobody likes like a ugly looking game. So it's yeah, I would say video games are or like even CG movies, and also what's very interesting, like high levels of scientific progress, mathematics or geometry, is explained in a visual way. So most often, I tend not to read any structural engineering papers. I go straight to computer graphics papers because they simplify it, and it's also visual. So AI papers, there's thousands of AI papers, but I try to find AI for computer games. Okay. Then it becomes palpable, tangible. Right. And then you have a carrot to learn it, right? And so yeah, at least something like that, like design and visual output has always been a carrot for me to learn complicated things, because I don't have a background in any of. When I first came to London, the only thing I knew was English, so it's which I was very good at, and now I guess it's useful in the prompt engineering world. Yeah.
And the last question we've also been asking a lot of people is 2024, there's a lot going on, game engines, AI, digital fabrication. Is there anything in particular you're really excited about on the horizon in the space of design technology and the AEC space?
Yes, I'm particularly interested in, over the last 5 to 6 years, I've been interested in the ideas of cities and how high performance geometry and these kind of digitally fabricated building components, material saving, circular buildings designed already for disassembly and so on, like the footbridge that we designed and demonstrated with the Block Research Group, for example, showing innovative ways to use concrete. So cities is a good way to scale things up, and it's also a good green demand generator, so to speak. So I'm particularly interested in AI for architectural intelligence for new cities, because countries like India, like Southeast Asia, Sub-Saharan Africa, they need cities. Yesterday I read a statistic that for every new citizen in a city in the developed world, there are 18 new citizens in the emerging economies. So the world needs thousands of cities to host up to 2.5 billion more people that are going to be urbanized in the next 25 years. And so it's a massive opportunity for architects to be relevant and target all of our skills towards. So I'm very excited that 2024 is probably going to be the start of the next 25 years. 2050 is where the world is going to be 70% urbanized. So
exciting times. We'll finish on that high note. So, yeah, thank you so much for your time. It's been super interesting to see the space and have you. And I'm sure we'll have you again in the future.
Yeah, thanks for coming, and thanks for the chat.
All right, guys, thank you for joining us on this tour. This was a super interesting one. Big thank you to Shaajay and his team for showing us around, and a great chat and some really interesting points. As always though, if you like this episode, please give us a like and a subscribe to help grow the channel. Otherwise, we'll see you in the next episode.